Okay, so I wasn't gonna make another video, but real fast I'm gonna try and show you this idea. So look, something that's very common when we look at large deposits of sedimentary rocks is we typically see sandstones, mudstones, and limestones in sequence. And that's what we're seeing when you go to the Grand Canyon. And so from the almost the bottom of the Grand Canyon, there's a huge deposit of sedimentary rocks. And everything you see here is either a sandstone, mudstone, limestone, or a combination of. And so a typical sequence we see is a sandstone, which is this bottom layer here, that's the sedimentary stack, and then a shale, which we're going to interpret as a mudstone, right? We use that term interchangeably. So sandstone, mudstone, limestone. And then a huge limestone, and then this group here is made up of mudstones, sandstones, limestones, sandstones, mudstones, and just that repeating stack over and over again. And they tell us something. Number one, you usually get these really thick deposits at coastlines, because this is where most of the material is being washed into from the highlands, right? So we have a high area and a low area. We're weathering, eroding the high, that all material is moving down with gravity into the ocean basins and depositing there and filling up these ocean basins, right? Of course, the other thing that's happening here is we put a lot of material onto the crust. It actually makes the crust bow down a little bit. So we can keep adding material even as the crust is kind of sinking a little bit. And this allows us to get these really thick deposits. But what I want to show you is, what does this mean? Sandstone, shale, limestone. So sandstone, mudstone, limestone tells you something about what the sea level was doing at the time. Okay? And so a sequence like this tells me that, remember, old, younger in the stack. If I never moved, it tells me at one point I was standing in sandstone. This is a beach environment. But then my environment changed and I was standing in mudstone. What does that mean? Now it tells me that sea level has risen and I'm actually offshore. And then finally I'm in limestone. Sea level is even higher because now I'm out by where the coral reefs are being grown and created. And so it tells me that sea level has increased from this point to this point. And if it was reversed, it would tell me they decreased. So look, I'm going to try and show you something and see if it works. So when you look at the canyon, you see this vertical stack of rocks. But when we look at what is happening during deposition, what we get is, let me play the game over here with all my whole thing. So if this is a side view, so here is a side view of the coastline. So it kind of gradually goes down like that. So that's my land surface, and then I come over here and I have some water. So here's the, let's put it here. So here's the water, that's the ocean. So what I typically see is that we get sands being deposited. As a river flows in to the ocean, it dumps sands, right? So that's the heaviest stuff, so it falls out first. And so I get sand at the beaches. And so this is where most of the sand gets deposited. And so as I move further away from the coast, what I see is I get muds being deposited. Why? Because these are the smaller pieces, and they're lighter, and they will settle out once I get away from the crashing waves, and I get deposition of muds out here, which will eventually turn into a mudstone. The sands will eventually turn into a sandstone. And then farther out, let's use this crazy purple, I get carbonate being deposited from the coral reefs, because now I'm out where the muds are all gone, sunlight gets through, and I can grow my coral reefs, and I have lots of carbonate, which eventually turn into limestone. So I have sandstone, I have mudstone, I have limestone eventually. So how do I get this to be equivalent to a stack of rocks that I see in the Grand Canyon? That is because sea level is moving up and down over geologic time. And so if we say, what if sea level is rising? So I have a rising sea level. Let me find my ocean here. So let's say that sea level is now here, up here. So what does that do for where things get deposited? So I'm going to take my I can get rid of that. Now what I see is, I see that my sands are now being deposited up here, where the river is entering into the ocean and is making my beach. So my beach environment's now here. What about my muds? Well, my muds have moved also. They're actually being deposited up here, right? And what about my carbonate material? Well, that's also moved. And that is being deposited up here. So now maybe you can start to see, now I've taken my muds and I've started to deposit my muds on top of where the sands used to be. So now I start to get a vertical stack. And of course, we could argue that we go even further inland, and now my thing is way up here is sea level. Get rid of this other one really fast. Go away, go away. All right, and now what happens? Same thing. My sands keep moving up this way. All right, my muds keep moving up the other way. My muds are now up here, and my carbonates have now shifted to the left here. And so now I got carbonates that are over here. And so now if I look at this stack here, I can see that right here, right there, I've got sand. Then on top of that, I've got mud. And on top of that, I've got carbonate. So a sandstone, a mudstone, and a limestone would form, and they would be stacked vertically like that. And so in the rock record, when we see a stack that is sandstone, and then there's some mudstone, that's supposed to be an M, and some limestone, it's an indication that sea level has gone up. And of course, I'm apologizing for everything you're seeing here. If I have it the other way, sandstone, oh Lord have mercy, mudstone, limestone, it tells me sea level is dropping. Now there is another explanation, of course. We could have the land surface moving up and down, but it would be just like sea level was rising and falling. If the land surface was sinking, it would be the equivalent of sea level rising. If the land surface was being uplifted, it would be the equivalent of sea level dropping. And so this sequence in the Grand Canyon, I can go there and look and say, hey, I have a stack of sands and then muds and then limestones. This is telling me that over geologic time, the environment has changed at this one position. Because remember, if I stand right here, I don't move, but this is what happened a long time ago, and then this is the more recent, and then that's the most recent. So it's a time thing. I stand here and I'm in the beach. Now I didn't move, but now my beach changed into this offshore environment where muds are, and then it changed to this even deeper water where there's limestones being formed. Right? So to be able to interpret these as a general rule of what's happening at the coastline, sea level rising or falling, and we can look at the canyon and see that there's hundreds of these kind of stacks that we can interpret as rising and falling sea levels over geologic time. So here maybe is a little better drawing of all that. And so what we see is sand, mud, carbonate, right, and as my coastline. And as that moves, right, I start to move things to the left. My sands come up more into the land, my muds go over my sands, my carbonate goes over my muds, and we keep doing that. And now we get what I attempted to draw in that little image there, which is a stack of sands, muds, and limestones that we see. And that's an indication in this orientation of a sea level rise. Because at the very top there is shallow marine, and at the bottom is where I was at the beach. I was not in the ocean. So the ocean must have moved into my area, and then I'm underwater. Right, so to be able to interpret these sea level changes based on rock types is very common. We kind of see this, like I said, lots of these thick sequence of sedimentary rocks are happening at coastlines. That's where all the sediment is going. So we commonly see these kind of moving up and down of sea levels. Okay, hopefully my drawing did not horrify you, and this makes a little bit of sense.